Up next, we have oral presentation number 19, Ector County, Texas, Team 2. This is a Mission 13 finalist proposal.
My name is Chloe Shaw, and I am the co-principal investigator of our research. Heaven Treviso is the collaborator, and Nayeli Yoringa is also the collaborator, and unfortunately today, they weren't able to make it to the conference. Mrs. Bright is a teacher facilitator. We are from OC Tex in Ector County, Texas. The title of our presentation is The Life Expectancy of an Active Leukemia Tissue Sample and an active leukemia tissue sample. Some background research before designing our experiment had us researching about leukemia and acute lymphoblastic leukemia, also known as ALL, such as how leukemia affects bone marrow and the white blood cells, and also what the common age range for acute lymphoblastic leukemia is. In this bone marrow picture, we found that if left untreated, the white blood cells will overcrowd the red blood cells. The red blood cells can't function and carry oxygen to the body. The white blood cells are too crowded to function. The patient has difficulty fighting illnesses with the weakened immune system, and that can result in serious fatality. It can spread to various organs, and there are serious health concerns. And because of the acute nature, it requires timely, aggressive treatment. In this leukemia percentage chart, there are many different forms of leukemia, but only 5% of the patients diagnosed with leukemia have ALL. So why are we interested in ALL if only 5% of patients are diagnosed with it? As you can tell in this age range chart, ALL is more common in younger ages, especially ages ranging from 0 to 4 months. As you can see, ALL has such a great impact in such an innocent population, and this immediately caught our attention for further research. Our main questions were, how fast can the radiation kill off the tissue sample, or if it will even kill it off at all? Can the radiation that your body is exposed to in space kill off the cancer quicker than the radiation used down here on Earth? Our hypothesis was, we thought that natural radiation would be a more effective treatment to cancer. A further explanation to that is, we thought that it would eradicate the cancer. Our experimental design sought more information on these following questions. How does radiation thoroughly affect the human body and the white blood cells? How would the change in gravity affect the sample? Is the treatment for each case of leukemia different from the others? And part of figuring out our treatment, do they have to locate what bone is cancerous, or do they just treat all bones? After our many attempts of planning out our proposal, these are the questions that still challenge us. Our expert helped us recognize these challenges that we did not recognize in the beginning. Our lack of incubator, we did not have access to a lab to do testing for ground experiment. We did not know a specific dose of radiation to use, nor did we know what type of radiation needed to be used. After analyzing these challenges that we encountered, this is what we hope to expand on in future studies. We want to hope to expand treatment options, and we want to further our research using stem cells. This is what we hope to accomplish. We hope to accomplish a more effective way to reduce the growth of leukemia, to see if man-made radiation is more effective or if natural radiation is more effective, how this type of radiation treatment would degrade the DNA of cancerous cells. As a team, we hope to accomplish these ideas using our future studies. This is who we would like to thank. We would like to thank everybody that sponsored our trip, our principal, Mr. Ramirez, and the teacher facilitator, Mrs. Bright. Thank you.
Do we have any questions for this team?
Hi, Tim Livengood, NCSE. So you mentioned the difficulty with knowing the radiation dose that your organism gets. There actually are tiny little dosimeters called thermoluminescent crystals that you could potentially pop inside the FME along with your sample. So that's something you might want to look into, whether there's anyone in your area who, like at a hospital or a similar facility where they may have access to that kind of device.
Thank you.
I'm Jenna from Grantsburg, and I don't have great advice like that for you. But, so could you clarify, is your sample the cell, or is it cell in bone? I missed that part.
We didn't know if we wanted to use like a tissue sample or if we wanted to use a bone sample, but we didn't actually get to do that part because we couldn't get a lab for ground testing.
Okay, so what did you send up?
We didn't get to send anything up.
Oh, okay, all right, I missed that part, I'm sorry. So my question then with that is, did you consider that radiation, natural radiation in space, would have an effect on killing off both white and red cells?
When we were doing it, we didn't, and I didn't think about that, so you just mentioned it, but that's a consideration that does need to be taken into effect.
Okay, thank you.
Hi, I'm Mike from Galloway, New Jersey. So you mentioned difficulties working with human cells and cancer cells. I'm wondering if you've ever thought about using some sort of model system, like a model organism that you can substitute for a human cell, and then not have to worry about those types of challenges.
Our expert told us to think of like an insect, but she didn't really elaborate into that, so we were kind of stuck on that, but we did think about it.
Good, thank you.
Any other questions? Okay, thank you very much.